Hi everyone, welcome to Math Moment with Mr. Dustin. I am Mr. Dustin. So today we're going to be discussing logic and reasoning. Now this is a concept in math that is generally covered in a high school geometry course. However, the applications to it are very useful for middle school students as it is important to learn how to logically think through something and come to a conclusion that is good for a situation. That sounds very vague, but we'll kind of get to the bottom of that through this video. And so let's get into some terminology that is important to know before we start actually proving anything, because this is definitely something that will go with proofs in geometry. And so the first thing I want to go over is similar versus congruent triangles. So what does it mean for triangles to be congruent? Well, the corresponding sides are the same length and the corresponding angles are equal. Now, what does that mean? Well, corresponding sides refer to sides of the triangle that are kind of like the same in where they're placed. So for example, you can see in these two triangles on the right here that the bottom sides are what you would call corresponding sides. They're in the same place of the triangle, and that's what makes them corresponding. Now, in math, what we like to do with sides to tell that they're the same is to label them as having like a dash here like this. So you can see like the one dash that I'm circling here is the same length as the one dash that's over here. Similarly, you can see that the 2 dash is going to be the same length as the 2 dash on the other triangle, and then the 3 dash over here. So what this tells us is that each of these corresponding sides are congruent, or the same length. And then corresponding angles are going to be a similar concept. The angle in the same place the triangle, so angle A on the yellow triangle is in the same place as angle D. And we do a similar kind of labeling method where you have the one line angle here is the same as the one line angle over here, and then you see 2 lines, 2 lines, 3 lines, 3 lines. And so what that tells us is that each of those angles that have the same kind of label on them are the same, they're equal. And we can see that those are corresponding. So these two triangles are congruent. And just in case you're curious about the symbols down here, this symbol with the equal sign and the like tilde over it, that means congruent. And then obviously like triangle in front of it. And then you label triangles by the 3 angles, A, B, C, D, E, F. Now, similar triangles are triangles that have all corresponding angles equal, but the corresponding sides are scaled by the same factor. Now, this second part of the statement, the scaled sides, is guaranteed with the corresponding angles being congruent. So let's take a look at some similar triangles here. We have a big group of them down here. So the easiest way to kind of look at this is through the green and the light blue here. Now you could kind of see that like the green is smaller than the light blue as far as the sides go. They don't quite line up in length there. But remember the signs that we found on the above triangles. The single line angles are congruent, and then the 2 lines and the 3 lines. So that's what makes these triangles similar. Each of their corresponding angles are congruent. And so similarity in triangles is much easier to prove than congruence, obviously, because there are more conditions to meet for congruence. So now that we have that terminology straight, let's look at some triangle congruence theorems. And these are different ways that you can tell that 2 triangles will be congruent. They will guarantee that they're congruent. So the first one is side, side, side. And that refers to each of the corresponding sides are congruent. So you have the 2 1s here, and then the 2 dashes, and the 3 dashes. So we can clearly see that those are all the same, like those corresponding sides are all the same. And you can kind of tell, it's a good starting point to like look at the shortest side or the longest side and say, hey, this side is like this side over here. in that they're the shortest sides on the triangles. So are they congruent? And that's what you would find out. And then you could look at the 3' sides and say, hey, these are the longest sides on the triangles. Let's see if they're the same. And so that's kind of how you would go about proving the side, a triangle. Another theorem that we use is angle, side, angle. And what this means is you have an angle, and then a side, and then an angle, which sounds really repetitive, but they have to be like right next to each other, adjacent to each other is what we would say. So you basically have one side that is sandwiched by two angles, and the corresponding angles have to be congruent, and then the corresponding side that's labeled also has to be congruent. And so we can see that because of this, these triangles are congruent. Now, why does this guarantee that these triangles are congruent? Well, if you know two angles, you can figure out the third angle because we know that all triangles add up to, or all the interior angles of the triangles add to 180 degrees. And because we know that, like in this first triangle, for example, A plus B plus C is 180 degrees, we can subtract A and B from that to find C. So that'll tell us the third angle. And then the sides will also be congruent because we know one of the sides. If you were to change the length of any side on this triangle, those angles would change. So you would have to scale all the sides by the same thing to maintain the congruence between all the angles. That means when you know that one side of the triangle is like congruent with another, side of a different triangle, you can, as long as you can guarantee that all the angles are congruent, that triangle will be congruent, or those two triangles rather will be congruent. Now, I know that was a very complicated explanation, and I'll kind of draw what I mean on these angles here because we can guarantee that. Let's look at a similar theorem, side, angle, side. Now, what this is going to do is it'll prove like the same thing, just using two sides and an angle. And again, the angle is sandwiched by two sides. So since we know that one of the angles is congruent, then we could take the two adjacent sides, and in order to adjust like those sides, we would have to adjust the angle, and that would mess everything up. So that means we can guarantee the congruence of the two triangles by side, angle, side. And remember, these are all corresponding sides and angles that have to be congruent. Another theorem that we use is angle, angle, side. And this is going to be a similar idea to angle, side, angle. Because, like I was saying in angle, side, angle, we can guarantee that the third angle is going to be congruent. So you would do, or you'd apply a similar method of reasoning to these two triangles. We know that angle A and angle F are congruent. So after knowing that, that basically just gives us angle, side, angle again. So these are important theorems that are basically going to be the ends of your proofs for proving triangle congruence. And it's very important to know these because the math community accepts these and will not question whether or not that's actually accurate. And so it's an easy tool to use to prove two triangles are congruent. With that, we're going to go into a break. And after that, we'll get into what it actually means to prove things and how to go about doing that. So enjoy the break. All right, so for the break today, I decided to show you a bit of what I do in the library. So I do something called shelving, where I put the books in order on our shelves, and in order means alphabetical order. So you want like the A's to come first and then the Z's to come last, that kind of thing. And so what we do is we shelve by an author. And so this is Daisy Meadows. These are all by Daisy Meadows. I figured it would be the easiest thing to show here. And then when the author's the same, we go by the title. And so that's what I'm going to kind of do here. And I'm going to apply some of the logic and reasoning concepts here, more of like working through things in a logical manner to figure out a proper conclusion. So what I know about the alphabet is that A comes first. Now, all of these titles start with J. You have like Juliet, Jasmine, Joy, etc. So I want the A's to come first. Well, how many JAs do I have? Well, I have Jade, so that's a JA. Jasmine, it's a JA. Let's see. No. Okay, so I'm going to set the rest of them aside. Now, we got to have a tiebreaker between these two. So, JAD or JAS. Now, D comes before S, so Jade is first and Jasmine is second. All right, let's go back to all of these over here. Now, I know B comes second, but JB doesn't really occur all that much. So the next one I'm going to go with is E. That's the next letter, so to speak. So we have Jesse, we have Jennifer, Jessica, and then let's see, those two, no. These two, no. No, that's the same book. That'll be easy. Okay. So, now, I know that N, which is the third letter of Jennifer, comes before S. So, this one has to be third. Then, between these two, this is kind of interesting, because we have Jessi, Jessi. So, what comes next? C or, well, here's C or E. Well, C comes before E in the alphabet, so that's going to determine the order of those. So far, here's our order. Now, I know O is a good vowel, but we don't have any JIs, so looks like it's either O or U. So we have some O's here. And actually, I'm going to start a new row, because that'll get them all in one shot. Now, does Y come before S? No, S comes before Y. And since these are the same book, they can go right next to each other. And our final one, Juliet, will go here. So now here's our order, going from the top row to the bottom row. And it was just a matter of using some logic steps to try to, find this order. So I hope you found this kind of insightful as to where these kinds of steps can be useful, and we'll continue with the video. Hi everyone, welcome back. I hope you enjoyed the break. So let's move on to other useful properties for proving triangles are congruent, among other things. We have what is called the reflexive property. And what this does is it says, hey, two triangles that share a side are going to have that side be congruent. So in triangle ABC, the side CA is going to be congruent to side CA in triangle ADC. So that's kind of the idea behind the reflexive property. The shared side is going to give you like a freebie, almost an automatic side. Vertical angles, which are over here, are going to be angles that are formed by the intersection of two lines. So these two angles that I just labeled around C are going to be congruent. They're across from each other. You can think of it like an hourglass. That's kind of the shape that it's forming. So the two opposite sides of the hourglass are going to be congruent. Similarly, if you're looking at exterior angles, we could say that these two sides are congruent. They are also vertical angles, although we won't look at them very much when we're looking at triangle congruence. And you'll notice that since we know that C is a vertical angle, we could say that that these two triangles are congruent through side, angle, side, because they gave us these two angles being congruent and these two sides. Yeah, these two sides are congruent and these two sides are congruent. So side, angle, side. Now, We also have what are called perpendicular lines. And what perpendicular lines do is they intersect and produce a right angle. So that's what you can see here by that box. That signifies a right angle. And what is handy about that is if you know one side has a right angle, the other side is also a right angle, because 90 plus 90 is 180, and that fills out the supplementary angles there. So it's a very helpful theorem to know. And you'll notice if we use the reflexive property, we can prove those two triangles are congruent now through side, angle, side. Now, another thing is the bisector. And what a bisector does is it divides a line or an angle in half, which means on one side of your bisector, it's going to be the same as the other side of your bisector. So in this case, CP, which is the middle line here, is the bisector, which means it produced like side AP is going to be the same as side BP, which is kind of funny. Those are both acronyms, AP for advanced placement and BP for blood pressure. Anyways, so using that, that's kind of the other theorem that helped us prove that those two triangles are congruent. And you'll notice I used the same diagram. So you got a perpendicular bisector. That's kind of something that will be given pretty frequently in a problem like this. Now, in order to prove something, you're going to use a no-show table. And what this means is you have a side or a column of your table that gives statements. This is what you know. And then reasoning, which is going to show why it's true. So like you know something and then show why it's true. So let's follow this proof real quick. Now, we are given a diagram up here, and we're also given a statement that side BC is congruent to side CD. So a helpful thing to do would be to label your diagram. BC and CD are congruent. We also know that AC bisects the angle BCD. And so what that is telling us is that this C right here is bisected. And so that tells us that angles 1 and 2 are congruent. So then it wants us to prove that the two triangles are congruent. Well, let's go through what we know first and try to prove that they're congruent. So the first step here is to list what you're given. So we're given that BC and CD are congruent, and your reasoning there is given. That's all you would need to put. And then angle 1 is congruent to angle 2. That's kind of the step that I just said, because AC divides the angle BCD into two congruent angles. And you could use like definition of bisect or something to that effect. That's how you would know it. Then the next step that they give is that AC is congruent to AC through the reflexive property. And that's what we just learned on the other page there. And yes, that is true. They share a side. So now we are ready to prove that these two triangles are congruent. And so you say triangle ABC is congruent to triangle ADC through side, angle, side. And you don't necessarily have to list the rest of this text here. Side, angle, side, or SAS will be sufficient for anyone to see that they're congruent. So you can see you have these steps here and then the reasoning for each step. And that's kind of the idea behind a no-show table. So I have two proofs here that we can go over together. So these are some examples that might be helpful to use. Now we have two triangles in this diagram here, and let's read what's given to us. So AB is congruent to AC. So that's going to be these outer sides here. And you can see they've labeled it with the 1 dash. AD, which is the middle line here, bisects CB, which is this bottom green line, at D, which is a point here. So when they say it bisects, we know that these two sides here are going to be congruent. We also know that these form 90-degree angles. or we actually don't know that. Sorry. We know that these are going to be the same. I have a feeling they're 90-degree angles based on the drawing, but you can't actually conclude that. So we have a no-show table here. And I'm just going to list the two things that are given. That's the first step to it. Now, what else could we list about this table, or this diagram rather? Well, this is a shared side, so the reflexive property applies here. And let's see. Okay, they also said that CD and BD are congruent, and we went over that already. And then here's the reflexive property that they're showing. AD is congruent to AD. So that means that these triangles are congruent. And additionally, angle C is congruent to angle B by CPCTC. Now, what on earth does that mean? Well, that means corresponding parts of congruent triangles are congruent. So CPCTC. That is an important part, or an important definition that you can use, an important theorem. And that just helped us prove that angle C is congruent to angle B. Now, why does this work? Well, if you prove a triangle is congruent, that means all of the sides, the corresponding sides, are congruent, and all of the corresponding angles are congruent. So even if you prove a triangle is congruent to another one without using a certain component, once you've proven that they're congruent, you can use CPCTC to say that any other corresponding parts of those two triangles are congruent. It's a very helpful tool for that. We have one more example here. And I know this video is probably going a little long, but that's okay. So this time I'm going to kind of write no and show, just to kind of get that idea across. It's a no-show table, although one side would be your statements and the other is your reasoning. So what we're going to do is prove that triangle ABF is congruent to triangle ECD. And so we're given that FE, this could take a bit, FE is congruent to BC. And these are both lines. So let's see, FE is going to be here, and then BC is going to be here. Okay, that is a little tricky, but it's good to have. It's given. So then we also have AB is parallel to ED, and then AF is parallel to CD. So let's see, AB is this one here. It's parallel to ED. So this little arrow shows that two things are parallel. And then if you do two of them like this, it shows it's parallel to something else. So I'm going to just kind of circle this part and put it right here. And then say it's been given. That's a very small v. Given. All right. Now we want to prove that the triangles are congruent. So how do these parallel lines help us? Well, we'll figure that out. The first thing I notice is the shared side, right? EB. And that's very helpful because that gives us one full side that they share. So EB, there it is, EB is congruent to EB. And that's going to be because of the reflexive T. Then we know that we have parallel sides here. Now, something that has been very helpful is when you have two parallel lines that are cut by what you call a transversal, you can have different angles that you know are congruent. So, for example, I know that this angle here is congruent to this angle here. So we'd say angle B is congruent to angle E. And that is by a theorem that is called alternate interior angles. Alternate meaning opposite sides of this transversal, which is like this FC line here. And then interior meaning inside the parallel lines, which are AB and ED. So I'd say angle B is congruent to angle E. And that would be by alternate interior angles. Then we can also say that C and F are congruent because of the same reason. They're alternate interior angles, but just on the same like, or the different side rather. And yeah, that angle would form, if you continued like each of these parallel lines out, those angles would be down there. It's just a little odd. So angle C is congruent to angle F. And again, by alternate interior angles. Now, I think we are ready to prove that the triangles are congruent by angle side angle, because we have an angle up here and then the full side and then the angle down there. So let's see, we'll do triangle A, BF is congruent to triangle, let's see, E, D, C. That's not exactly proper grammar, but we get the idea here through angle side angle. And the proof is done. So that is basically how you fill in an entire no-show table. Just start with what you're given and then use the theorems that you know to conclude something new. So to summarize, congruent triangles are triangles with corresponding sides that are the same length and corresponding angles that are the same, that are equal. Similar triangles just have the corresponding angles equal, but the sides are scaled. And then triangle congruence theorems include side, 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 angle, side, angle, and angle, angle, side. And then a no-show table gives a statement and then a reason for why that statement works, and it is very useful for organizing proofs. So when you're writing a proof, start with the information that is given and then use that to conclude other things until you reach the conclusion that you're looking for. And so that's the basic overview of logic and reasoning. And so there is a quiz that you can take, and the link is in the description below. These quizzes are available until August 7th when the summer reading program ends. But you can still come back and watch the videos anytime you would like to. They're going to be up on YouTube permanently, as far as I know. And so we have one more video after this, and I hope you are able to make it to that one. Otherwise, thank you for watching, and we'll see you again next time.